Everybody, it's Tyler here at Kettering Kickoff Day 2, checking team number 226, Hammerheads, a fantastic team. They've been doing so well here at Kettering Kickoff, definitely ranked in the top 8 as we close out our qualification rounds as well, too. By the way, I'm here with Sonica, a Cool, and Anish, and this robot here, a great design. We'll follow a cargo path all the way through, talk about their shooter and their climber, learn more about this great team coming up here on Behind the Bumpers.
First Updates Now is made possible by viewers like you and also the following sponsors. Continue your excitement of robotics at Kettering University with their combat robotics team and First Center. Turn your robotics experience into a professional career. Find out more and get your application started at kettering.edu/apply. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com.
So cool, let's start off with that cargo path. Talk to me more about your intake. You guys have a lot of compliant wheels on this in a couple different colors. I'd love to hear just about that configuration too.
Yeah, so originally we started off with 2 sets of 3-inch compliant wheels and then the 2-inch compliant wheels at the top. But we found that it wasn't as efficient at picking up balls. Now with these 4-inch compliant wheels, they become more touch it, own it.
Sure.
So it's become very easy to just touch a ball, pick it up, bring it through, and it's very efficient. And we've had no issues with it really. Just if we like hit something like pretty hard, some things like will break a little bit. It has been fragile early on in the year, but then after about states, we decided to make these polycarb plates thicker, more strong, so that they broke less easily.
So you have it is a pretty compliant intake still, but yeah, definitely this rigidity that's been added here, you can definitely tell the big difference on that as well too. Can we see that cargo piece come in and we'll see how that intakes?
Sure.
I do want to ask you on this pivot here too that you have. Have you found that's been better for like impacts, that sort of thing?
Yeah, because we found that helps with bouncing balls a little bit, and it allows for a more consistent contact throughout the whole travel. And then of course the extra pivot, I guess passive roller.
Yeah.
It's static, but it helps to just extend the bumper area and allow the ball to more easily contact the bumper and be fully controlled throughout the whole intake.
So Anish, as we jump into your cuer that you call it on here, kind of start initial impact here, then you got that bend. I'd love to just hear more about how you came up with figuring out how that bend's going to work, because a lot of robots have to deal with jamming, that sort of thing.
Right.
Then we'll talk about your shooter too.
Right, so we start here with the cuer. It comes with 1 set of wheels over here. Just pulling it away from the cuer, we kept the distance such that you'll be able to have the intake and the cuer's like transmission of the ball much easier. Then we had a little, if you look in the back here, there's a little slide up with the polycarb that allows the ball to just slowly flow up the intake just smoothly like that.
Yeah, it's really smooth.
Right, and what we did was we just tied 1 Falcon motor and tied a bunch of these pulleys together down in a chain to run all of these wheels in a 1-to-1 ratio, I believe, and just have the ball slow move up and down. We usually run this around like 50% speed. Using it above 100 starts becoming a little bit weird.
I want to ask you on here too, you have the different Durometer wheels as you go through. Is that an intentional choice, like, or is it an aesthetic thing? Like, what's gone into that?
Sort of aesthetic, sort of functional. If the ball's like a round thing, so we wanted to have a little bit more flex on the center and allow it to be a little bit more stiff here, so we maintain that compactness of the cuer, but
Sure.
not like squish the ball too hard so that you aren't able to move it up the cuer anymore, and you need a lot more force to move it.
Going into your shooter here, looks like got a couple big Fairline wheels going into, so a good amount of flywheel. Plus you got that extra kicker one to get it through. Talk to me more about the strategy behind it.
So this one was actually one of our biggest improvements over the season, and off season of course. We actually started without this top roller and with Versa wheels on here, which we found at St. Joseph to be a little bit, it doesn't maintain its RPM very well after each shot. The RPM drops way too much. So we decided let's switch to these Fairlane wheels, which then have a lot more mass and they're a lot more thick, so they hold their momentum much easier without needing those, if you've seen them, the brass wheels from SDS.
Yep.
Just it allows it to carry that momentum through. And then the next thing at Troy Districts, what we realized was that the ball would have an insane amount of backspin. So what we ended up doing was just take our previous hood and add a top roller to it using a 775 with the Talon SRX motor controller. And we just put it up here and tuned it. Our tuning actually is also pretty, it took a while to do. For our tuning, we kind of take if you look at front here, we have a limelight. We kind of calculate the distance from the limelight and plug it into two separate equations. We have a quintic equation for our actual main shooter wheel, and we have a sort of piecewise function for our top roller, depending on the distance of how far we were. And that definitely took quite the time to tune.
I noticed that you do have some pneumatics here for different positioning. Where does Hammerheads like to shoot on the field? What's kind of your sweet spot?
We kind of like to shoot everywhere. Actually, in St. Joseph, we played with the hood out a lot. We played with the hood out so that we'd use these inner pieces to shoot up against the fender. But after St. Joseph, we realized at Troy Districts, we can just shoot with this down constantly and just tune our quintic equation so that we can shoot from any place that we really want. So yeah, we just like to shoot from anywhere.
Let's start to wrap up on your robot and talk about your climber that you had as well too, and show up your climber sequence. Hammerhead's really the complete package all the way through. So I'd love to hear about, speaking of packaging, how did you get this climber packaged so well within your robot as well?
So the climber, since the start of our design and building process, has been the most solid subsystem that we have. Since St. Joseph, from the start of the first competition, we've been able to traverse pretty consistently, and we're very proud of that one. And the way that we thought of it was that we'd want to have just one arm being the driving force behind moving from bar to bar. That way there's less ways that it can go wrong. A lot of teams are doing two arms, but we chose one arm as that one. We felt had the most simplicity, and overall we could manage better overall. One thing that we iterated on was the grippers that we have here that hold onto the previous bar while we're reaching for the next. Originally, we were thinking of doing an overlocking mechanism with a pneumatic piston, and then it would claw, but we eventually changed to this passive gripper such that when it just hits and then goes down, it'll pass and then pop back up, and then the bar will just hold it right there. And it's worked quite well. Anish, do you want to show it popping out? Yep. We wanted to try and be repetitive in terms of how we go from bar to bar so that it's the same exact process from the mid to the high and then the high to the traversal. So essentially it's resetting each time. And one thing that we noticed from the way we did our geometry, it was a very tight squeeze between our shooter wheel and our climber arm. So what we improvised essentially here is some climber blocks that would be obstructing it from touching the wheel when it's inward during normal teleop.
Yeah.
And then once the end game happens, we pop it out, these fall down, and then it comes all the way up so that it's all straight in line.
Oh, I love that thought process. We've seen a couple of climbers look like that, but I haven't seen the pneumatics come out for that. That's really cool.
So yeah, we found that, and there are often some mishaps where it does sometimes pop off. We had a couple of iterations with this as well, different material. Rubber is eventually what we settled on that worked the best, but it was a journey, yeah.
Well, Hammerheads, thank you so much for taking time to tell us more about your robot. As we mentioned, as we're filming this, a great performance so far here at Kettering Kickoff, so can't wait to see how you do here, but of course, good luck in future seasons. Look forward to your robots too.
Thank you so much.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Continue your excitement of robotics at Kettering University with their combat robotics team and First Center. Turn your robotics experience into a professional career. Find out more and get your application started at kettering.edu/apply.